Okay, so let's work this simple harmonic motion problem. And the first part of the question, we have some mass that's oscillating. We're given some parameters in the problem. The first question is to calculate the frequency of oscillation. And frequency, remember, is 1 over 2 pi times square root of k over m. So we plug this in and we get 1 over 2 pi. K is 8. The mass is 0.5. So this quantity here, 8 divided by 0.5 is 16. You take the square root of that, you get 4. And so we're going to leave this in this kind of strange form. 1 over 2 pi times 4 per second. Okay? It'll be obvious why we left it in this form in a little bit. And the question of part A is to find the maximum velocity and maximum acceleration. So Vmax is 2 pi f times the amplitude. Okay, now we can kind of see why we have this 1 over 2 pi in here, because it cancels out with this 2 pi. So 2 pi times this gives you 4 times the amplitude, which is 10 centimeters. So the 2 pi's cancel out here. And then you have 4 for this 4 part here. The amplitude is 10 centimeters. So that gives you 40, and we'll leave it in centimeters per second. Okay, so there's Vmax. Now Amax, maximum acceleration, is 2 pi f squared times the amplitude. So instead of 4 times 10 here, you're going to end up with 4 squared times 10. Okay, so the 2 pi's again will cancel and you'll have 4 squared. And that gives you 160. And that's going to be in centimeters per second squared. So we're just leaving things in centimeters for this problem. And just as long as we're consistent with that, it's going to be fine. So there's the answer to part A then. Now part B asks us to calculate the velocity and acceleration when x is 6 centimeters. Okay, so to do this, we're going to need our position versus time equation. And the position versus time function for simple harmonic motion is a cosine 2 pi f times time. Okay, so what we're going to want, to figure out the velocity and acceleration, we're going to know at what time it's at x equals 6 centimeters. So the amplitude here is 10. Cosine 2 pi times f. So 2 pi times this whole thing gives you 4 t. Okay, that's our function of x versus time. Okay, and so we want to know at what time is x 6 centimeters. Okay, so to solve that, cosine of 4t then, divide both sides by 10. Cosine of 4t is 0.6. Okay, 6 divided by 10 is 0.6. So take the arc cosine of 0.6. And to do this, you have to make sure that your calculator is in radian mode. Okay? All of these numbers in here are assuming that you're using radian mode whenever you're doing this type of thing. So you take the arc cosine of this, that equals 4t, and then divide that by 4 to give you t. So when you do this on your calculator, the arc cosine in radians of 0.6 is 0.927. So that equals this 4t part. And then you divide that 0.927 by 4 to get t, and that's t of 0.232 seconds. So there's our time. That's pretty crucial when we move on here. Now our equation for velocity versus time, these are equations that we talked about in lecture. it's negative v max, so negative 40, that was v max from part A, and it's sine of this stuff. Okay, so that's your equation for v versus t that we developed in our lecture. Now, here we plug in our 2.32 seconds, because that's when it's at x equals 6. So plug this into here, 4 times 0.232. Make sure your calculator is in radian mode, not degree mode, and take the sine of that value, 4 times 0.232. That gives you the number 0.8. 40 times 0.8 is negative 32 centimeters per second. So there's the velocity when it's at x equals 6 centimeters. Now acceleration versus time, the equation for acceleration versus time is negative a max, which is 160, which we calculated in part A, negative 160 times the cosine of this stuff in here, cosine of 4t. Okay? Now again, plug in this 0.232 number in for time here. 4 times 0.232 gives you some number. It's a little less than 1, like 0.9 something. Make sure your calculator's in radian mode and take the cosine of that. The number you get is, it's 0.6, I believe. 0.6 times negative 160 gives you negative 96 centimeters per second squared. Now these might seem like big numbers, but they're not, because remember they're in centimeters here. So this would really be in terms of meters per second. If you're interested in the meters per second answer, this would be negative 0.32 in units of meters per second, okay? And this would be negative 0.96 in meters per second squared. So, we'd expect these negative answers here. Because, if it's a positive displacement, you start when it's here. That means the negative means it's moving to the left. Okay, if you start with it like, if the spring is unstretched in the middle here, you stretch it out to the right, and you let it go when it's at 10 centimeters, and it's moving back to the left. So thus we have the negative velocity, and the negative acceleration is it's speeding up to the left.